So my MIDI techno is on Yocto tooling. You guys know I love Yocto, and you guys know I love Vim, so it's all gonna be in Vim, and it's all pre-recorded, so it's all gonna go smoothly. I don't have to pray to the demo gods or anything for it to work. So I want to talk about all the tools that you get available to you when you source Pokey, like the OE init build env script, and so that you can automate a lot of the common things you have to do when using Yocto and BitBake and etc. So some of the tools I'm going to be talking about are BitBake layers, setup build, BitBake getvar, BitBake recipe tool, dev tool, run QEMU, OE depends dot, OE package data util, OE run native, build history, collect source revs. Any chance you guys just give me a show of hands if you guys are, say you know like more than 50 of these tools?
More than 50 or
50%, sorry, 50%. Okay, there we go, perfect. Okay, because I just wanted to gauge. And so I'm not going to be using CAS or repo because I want to show you the official tools that come with Pokey and kind of show you the pain that comes with using them. So why I like to use CAS because of that, or custom scripts or etc. So first off, I'm gonna set up a sample project using all the built-in official tools. The layout I'm gonna have it's not ideal. It's not the layout I want to have, but with the official tools, such as like setup layers, you can only have like all of your layers be source controlled and not necessarily like the root of the project. Like here in this layout, Yocto project, I wasn't able to get it working with the official tools to have this be the Git repo and my custom layer as source code within that repo. I had to make this a layer, and in the documentation they call it a bootstrap layer because it will, well, we'll get to that in a minute. You'll see why it's called a bootstrap layer, but pretty much you use the layer you create to bootstrap the rest of the project structure from that. Ideally, with tools like CAS or other custom solutions, I would have the top level project be source controlled, and then our custom layers are just source code within that, and then obviously the other third-party layers and Pokey, etc., etc. So I'm going to show you how to set up this project from scratch using the official tools. So I'm just going to, so first things first, we need Pokey. So we're just going to clone Pokey in this Yocto project repo. And because I want to have like containerized builds and this PC is using Arch right now, I'm going to use like CQFD so that I can not have to worry about installing everything. Then I'm going to source the OE init build environment. And we'll just look at what layers we have available to us, like from the start, just with only Pokey, without adding our custom meta layer. And so we got meta Pokey, and Yocto BSP. So we can use this. We can use the BitBake layers show layers command to see what layers are available to us. It's also extremely useful to making sure that you know your layers are getting correctly picked up by BitBake. Like you could either do this, or you could kind of manually search for your layers and validate all the variables are set accordingly. But BitBake show layers is a great way of just validating that your layers are being properly picked up and they're properly set in the BB layers variable, and so forth. And so next I'm going to, so the hypothetical product in this will depend on Python. So I want to get meta Python. And so, but I kind of want to get some more information about meta Python before I bring it into my project. So I can use BitBake layers, layer index show depths to get some more information of the dependencies that meta Python has. So we can see that meta Python depends on meta OE, and both of these are in the meta open embedded repo. And next I want to, now that I've gotten some information about MetaPython, I want to add MetaPython to my project so I can fetch it directly from the layer index via layer index fetch. And I'm going to throw in shallow so that it's a shallow clone, and fetch dir so that it gets put where I want it instead of in Pokey, because by default it's in Pokey. And so I run this, and you see it clones all the layers I need, and automatically adds them to my BB layers, my bblayers.conf, and etc. And that's great. That's really nice. That saves me a lot of effort from having to go look online to get the remote for Meta OE and Meta Python, and make sure I'm checking out the right branch and checking out the right commit. This already handled all of that for us, which is nice having it all kind of handled for you instead of you having to do a lot of manual validation yourself. And another great subcommand of the BB layers command is show recipes, and you could specify for a specific layer. Here I'm doing, like I want to see what recipes Meta Python added in. I'm so glad it's pre-recorded so I can just skip through that. How great would it be if you could do that in like real life with Yocto? Yeah. So I can see all my layers. So it's great, very, very good. That's also a really good tool for validating that the layers that you're adding are getting properly like picked up by Yocto and BitBake, and you can see that BitBake sees your layers exist. So if you're ever having like issues with BitBake not being able to find the recipe you just created, is a great way of validating that. And so I changed my mind. I don't want Python in my product, so I'm going to remove that layer, but I also have to remove Meta OE because I just have to be explicit about it using the BitBake layers remove layer subcommand. And so running that, and then I run BitBake show layers right after that, and I see that it's no longer in my layers. But I also have to manually remove the source code that got cloned because remove layer doesn't handle actually removing the source code. So perfect. And now I want to add my custom layer. So I'm going to use the BitBake layers create layer, and this is in reference from like the build folder, so I have to go up to source. And we're going to use metavader because it's a pretty sick name. And for the using like the official tooling, all your layers need to be Git repos. And so I'm also just going to initialize it with an initial commit and etc. And this layer will be the one that will become our bootstrap layer. And yeah, perfect. So also, as you can see, so it's nice. The create layer command automatically kind of builds you the conf layer.conf and recipes examples, gives you an example recipe, and then readme copying, which is nice because the conf layer.conf is mainly just boilerplate. And you can also pass, so I don't want to have to be writing that manually. I want to be automating that. And you can also pass a priority flag to set the priority of the layer. I think by default, it automatically makes it higher than Pokey, at least. So, but this only created my layer. This didn't actually add my layer to the bblayers.conf. So I need to go in and do that. And so if I show layers, add the layer, and show layers again, we can see that it's not in my layers. I add it, and now it's in my layers. So perfect. And now, like the last thing the layer needs is kind of like the rest of the build configuration, like the machine and the distro. And I just added in a couple distro features and other options just for the demo. Yeah. And I'm going to just save that to my local.conf. And then, so to make this a bootstrap layer, I need it to be reproducible. And so the things I need to like reproduce are like the repos, the layers that make up the repos that make up the layers. So Pokey, and if I still had Meta Open Embedded for Meta OE and Meta Python. This first command here, create layer setup. This is the essentially what's going to be providing like the Git submodule like management. It's going to be tracking the layers that I added, track their remotes, and track their specific source revision. And then this, we'll just do the first one, and then we'll get to the second one. And so this is the built-in solution, so that you would use instead of using like Git submodules or repo or the features provided by CAS. So I create this, and so this creates these two files, this setup layers script and this setup layers.json. And so if I'll jump into the setup layers.json, and we can see it has all the typical information that we want in our like Git submodules or our CAS layers or etc. So we got the source revision, the branch, and yeah, all we need. So we got for metavader, and Pokey. Also something, a little downside that's interesting to note is that the source, like I had metavader and Pokey in source, but this doesn't really keep track of that information. So that's something I find as a downside of using this specific one, because in the future I'll need to manually recreate that source folder and put things in place, which is a little bit more manual. And if the more steps you add, the more likely there's going to be human error. So yeah, and then so that was the setup layers.json, and then you also get the setup layer script that sets up. That's running this setup layer script is like the essentially doing your git submodule update --init --recursive --force or whatever. And then for the next command is we got BitBake layers save build conf, and I pass it to I save. So this is saving a template. So it's going to save my bblayers.conf and the local.conf and some more like metadata to display when I choose to use this setup. Yeah. So here I run this command, and I know it's a little hard to see because it's just a bunch of white text, but see, now we have our template created from that command, which is in this template folder. It just has like the here. Yeah, I think I get to it in a second. Yeah. So these were all the template files I got added when I created that when I ran that second subcommand. And yeah, and then of course I want it source controlled so that when I go to use it again, it's when I like. This is what makes these layers, like these files here, is what makes this layer a bootstrap layer, and what makes it capable of reproducing the build environment in the future on different machines, etc. And as you can see, the sample has the information that I wanted in the local.conf and the layers that I wanted in the bblayers.conf. Perfect. And all right, perfect. And so that was how you set up a Yocto project from scratch with official tools. So you can see why I would rather just, or wait, I'm getting ahead of myself. Sorry. So now I'm going to show you how to use the Bootstrap layer, and then I'll explain why it's kind of nicer to use something like Cas. All right. So we clone the layer, but you see how I have to clone it specifically into source metavader because it doesn't remember that I wanted it in source inside the top of the repo. And I copy my CQFD config again. And so now to reproduce this setup, so I need to run that setup layer script that we saved into this layer. And so this is essentially the git submodule like update --init. Like this is us cloning in, pulling in those layers. And so it takes a second to run, and it clones in source pokey, but it'll just clone it in the same folder as metavader. And yeah, so that's how we pull in our layers. And then to set up the rest of the build environment, you kind of have two options. You can either use the setup build script that this also just put in your source folder. And so you could use this command to choose the template that you wanted, or you can use the classic oinit build env script, but setting your template via a template conf variable. And both of these kind of still feel like there's a lot that I need to remember to do to get set up into the build environment. So again, why Cas or similar tools is a little nicer. So here I can run. Here I got. So I can this setup build script that got added to my source folder by the setup layers script. I can use list, the subcommand list of it, to see the possible configurations I have. So here there's Vader. That's the one I had, and this is the one that by default, Pokey default. And obviously I didn't change any of the boilerplate like help information, so it says fix me. And so also to note, when we see that fix me, that means the config is properly it gets properly set up, because it'll get printed out every time we select that config. Here, like right there, fix me. Now I know for sure, right now I'm using that template. And yeah, see, now my conf local.conf is set up, and now my conf bblayers.conf is set up. And then I'll go show you how to use the template one. I'll remove my conf folder and source the template configuration. And so we get the same output. So this is like two ways of getting to the same build environment in Yocto. So you can see why that's a little cumbersome, and like why it's kind of nicer to just clone your repo, your Yocto project, and then run cast build or something along the lines of that. Yeah, and then from there you can start building. So that's how you can get set up with the built-in tools in Yocto provided by Pokey. And now I'm going to just go a little bit further into some of the commands like BB layers and some of the other commands I had listed at the start. Does anyone have any questions about any of that so far? No, we're going through. All right. So BitBake layers has so many useful subcommands, and what's so useful about them is that you know that BitBake has properly parsed these recipes to get all the variables. But something I found extremely useful is that you can use BitBake layers show recipes -inherit to see which recipes inherit kernel.bb class. I think that's pretty cool to be able to like inspect that fine grain of information inside your source code. And then there's some other other commands. So we can see here that Linux Yocto is the only recipe in my current source code that inherits kernel.bb class. Then there's some other commands such as bb layers flatten, where you could merge some layers. I personally don't think I'd be using that too often. There's BitBake layers show appends, so you can see all the BB appends taking effect, which is a great way of validating that your BB appends have been put in the correct place and all the variables are set up so that you know your BB append is properly being selected by Yocto. Of course, you can specify it by a recipe as well. And then there's also BitBake layers show cross dependencies. This shows the dependencies between recipes that cross layer boundaries, which is a great way to know what your layer really depends on, what layers your layer really depends on, which is also great for you to go and update in your layer.conf the layer depends of your layer so that you know that's properly specified so that BitBake can give you those warnings when you need them most. Yeah, perfect. So that's BitBake layers. And the next command I want to show is BitBake getvar. Do you guys know BitBake getvar? It's very, very useful. You just get a single BitBake variable. It's very nice. But it also shows you the whole history of that specific variable, which I find is really nice. Like here, I want to validate that my machine got correctly set from the template that I set earlier. And so here we can see so my machine is set to QEMU, x86-64. Great. And we can see the entire history in this comment above that's showing how this variable was constructed, how it changed while during the build or during parsing. And it's very, very convenient. And we can do the same for our distro to make sure that the distro got set appropriately. It did. But then you can get very fancy. You can be specifying based on recipes for specific variables. You can select, like here we just want the source URI of our virtual kernel. But you can also ask for the source URI of the unexpanded source URI. So before it, like when it was constructed of just variables, so before the variable expansion. So here in this example, we see that the variables are unexpanded in the output of it. So that's also very nice if you want. But most of the time, you can just see that in the comments above, like right here. Typically, you also just see that there. But I thought it was interesting that they had that little tidbit. And then, yeah. And you can also get specific var flags say, so this one, BitBake get var -f doc -- value source URI. This is getting the doc var flag of source URI. And so that's great if you explicitly want only one var flag. Typically, the BitBake get var doesn't show all of the var flags by default. I think it just, like if you don't explicitly select a var flag, it doesn't show any of the other ones. It'll just show doc by default. But if we want to explicitly look at one, you can do it there. Yeah. So that was BitBake get var. Very useful. Yeah?
What's the
-h
option?
-h, help. It's the most useful option for every single one of these commands. I highly recommend you use it like a lot. Yeah. So that was BitBake get var, and obviously BitBake. How can we forget about BitBake? You know, like it's what we use every single day. So obviously you can do BitBake core image minimal. So BitBake your recipe, just build your recipe. -k for continue. So if you want like an unattended build, you want it to continue as much as possible, even if it encounters an error. There's also -n for a dry run. And there's also -p for just a parse run, just to make sure that your BitBake syntax is correct, which can be nice. I don't find I use that too often. But then what I do use extremely often, like all the time, multiple times a day, BitBake -c to run specific tasks of that recipe. And then you can get some very important ones is list tasks, dev shell, py-dev shell, and like the common ones that get run as part of building the recipe. But list task is very useful because it shows you all the ones specifically for that recipe. And because sometimes recipes will add custom ones that aren't always available for every single recipe. So very useful. And when you use -c, you can either write the full thing, like do diffconfig, or you can just do diffconfig without, you can drop the do underscore. And yeah, very, very useful. Oh yeah, and dev shell, -c dev shell is one of the most useful ones. It puts you in a build environment with all the environment variables set, so that you can run like specific make or build commands as you want, and you can just do some quick little development. And it's very useful, very nice tool, very nice task. I highly recommend that you use it. And then yeah, and then extremely useful one, BitBake -e. BitBake -e. So I've shown you BitBake get var, but BitBake -e is essentially get var for every single variable in that recipe or in the build environment. So, and it's just a massive collection of all the variables, all the functions, all the tasks, everything. It's a great way to know and troubleshoot why the variables are the values they are, because again, they have the history above each and every single one of them. It's very, very incredibly useful. If you don't know about it, you really should. For Yocto development, I use it constantly. Another very useful one is the -- run all. So we can run one task for all the recipes in a specific image, or you could say world if you want like to download all of like this would download all of the source code, or the source code for world, like all of the recipes pretty much that you have in your project. So that's very great. Another one, -g, we'll get into that in a second. Yeah, so that's BitBake. Does anyone have any questions about the classic BitBake command? No? You guys are all super familiar with it? All right, perfect. Now recipe tool. Recipe tool is very nice for automating tasks that have to do with recipes. Yeah. Sometimes some of the subcommands with recipe tool, I'd rather just edit the recipes directly, but some of them are fairly valuable. But like for example, we can use recipe tool edit to edit the recipe. I'd personally rather just find the file and go to it, but it's there if you guys want it. You have to set your editor variable or your visual variable or whatnot for it to properly work. And so as you can see, I obviously set mine to NeoVim, and there I'm in NeoVim. We're moving around the file. So it's kind of neat. But yeah, and then there's also recipe tool set var, so you can explicitly set one variable in a recipe, which is, it's neat. I don't know how much I'd use it, because like this is kind of like, feels like a lot of boilerplate just to set like one variable. I'd rather just like find that file and like jump into it and change it. But it's interesting, it's there. And so I run it, and we can see that now the summary has been changed. And yeah, and one that's a lot more useful in my opinion is the recipe tool create. So you can point it to a project's source code and say create a recipe for that. And if that recipe uses some like common things, like if it uses like CMake, like recipe tool will be smart and know that source code depends on CMake, or if it depended on make, it knows that it depends on make, and it can generate some boilerplate for you in the recipe. Here, I write a super complex shell script, and I point my recipe tool to create a recipe for that shell script, and then it goes and creates a recipe for it, and then we can see this is the recipe it created. It wasn't too intelligent in that case, but it's a lot more useful when there's when like say the project where the source code you pointed it to is a Git repo where it can get more information, or if there's like other standard things. A really useful one, recipe tool new append. So this command is creating a new BB append on virtual kernel. And I specified -w to get the wildcard, so like the percent sign instead of the specific version of that recipe. And I point it to source metadata where I want it stored. And then yeah, that's very useful a lot of times. If you just want to just create it. The reason I find this very useful is because it automatically is smart about where to put that BB append. Like here we have the BB append being put in recipes-kernel Linux and there. But had I created that BB append myself, I would have had to manually think about, this BB append should go in recipes-kernel/Linux. And who knows, maybe I don't think about that and I put it somewhere else that isn't as standard. Like it's best to keep with the conventions of where the BB file was. So the recipe tool new append handles that for you. It knows where to intelligently put that. And then there's some other ones that, again, aren't the most useful, but it's still interesting to note that they exist. You can append specific files for specific recipes. Like we append hosts here for the Etsy host file in the hosts recipe. So there's some other cool things where you can like manually specifically change source code in projects without actually having to do all the work to get it set up. But yeah, so that was a recipe tool. Anyone got any questions about recipe tool? No? Okay, and now we're going to talk about DevTool. You guys know DevTool? Yeah? You guys like DevTool? Yeah? You should love DevTool. DevTool's so great. So here I'm going to use DevTool to add a recipe. So you could use recipe tool to create a recipe, or if you know you're going to be working with that recipe and want to change it a bunch, you can use DevTool to add that recipe. And so here, the complex shell script I had wrote earlier still exists, and so I want to add this complex shell script. Like I want to create this BB recipe based on this source code, and then DevTool's nice. It'll do the same thing that recipe tool create did, but put it in a DevTool workspace. So that's just a specific path in the build folder. It's like build workspace, sources, recipes, something like that. But that's very nice because like having these workspaces, DevTool can intelligently kind of remap the variables of like where your source, like the S variable in Yocto, it'll intelligently remap it to to point to your workspace. Why am I waiting for this? And then another nice DevTool command is DevTool rename. You can rename the BB recipe if it's like still in the DevTool workspace. And then DevTool finish is the command you use to say, I'm done working on this specific recipe. I want you to put it in the layer that I'm specifying. So here we finish simple script and put it in metadata. Yeah. And now getting into the real meat of DevTool, in my opinion. These are the main commands I use with DevTool when I want to patch a kernel, patch some source code. I use DevTool modify, the name of the recipe. And what DevTool modify does, it pulls the source code in, puts it in a workspace in your build folder, and now if you, which is very nice because I don't know if you guys have ever experienced going into the source code of a specific recipe, changing something, and then you ran the BitBake command and accidentally lost all the changes you just made. With DevTool modify, it allows you to kind of rerun the commands without having to worry about kind of losing the progress you had when working on that specific code base. And then also a very nice subcommand as well. I just learned about this for this presentation. Is DevTool menu config. Like I think you guys know BitBake-C menu config, but DevTool menu config is nice because it will automate a lot more than DevTool menu config. Because with DevTool menu config, you'd have to do DevTool menu config to modify some variables in the configuration of the kernel and whatnot. And then you would have to do BitBake-C save diffconfig or save defconfig. There's two. There's diffconfig and save defconfig if you want to save the whole defconfig or a config fragment. But with DevTool menu config, it knows that you automatically want to save a fragment of it. So here we'll go through and show. So first I run DevTool modify to put it in my workspace. So now Linux Yocto is in sources. And now if I do DevTool status, I can see that Linux Yocto is one of my current recipes I'm modifying right now. And then so you can see it's in the Linux source code is in workspace sources Linux Yocto. And then I can do menu config to get the menu config. And now I'm gonna change a couple config symbols and then exit. And we can see that that DevTool intelligently creates a DevTool fragment.config. And now when I run, and the fragment has the changes I made. Perfect. And now if we do a DevTool status, we see that my kernel is still in our workspace. And now I want to, I'm just going to run another command in dev shell that I want to run. And now when I go do DevTool finish on that recipe, this is the act of moving it from the workspace back to the specific layer that I want it to be in. So I also have to specify the layer to it. But sadly, I found a bug in this specific situation where it doesn't, DevTool doesn't respect source rev format. So I had to go in and kind of manually add something real quick, which you'll show in a second. But it was the fact that like the source rev specified for this specific recipe was source rev _ machine. So I had to go in and kind of manually add that. I do kind of want to look into possibly patching this in DevTool because it is an extremely useful situation that I would want to use regularly. So now after patching DevTool, I'm able to run the command again. And now we see copying DevTool fragment, and it puts it in metadata, recipes kernel, Linux Yocto, and then it also created the BB append to list that config. So it already has done so much boilerplate for me that I didn't have to, and I'm happy with that. I'm so content. Yeah. And we can see I run DevTool status. There's no more workspaces I have anymore. And we can see all the boilerplate that DevTool has done for us, and all I did was go into menu config to change some options. Very nice. Yeah, see, all this done for me. Yeah, and then another extremely useful one is like you may have modified a recipe, but now you want to just throw it away. DevTool reset -A for all. And also, very useful to note with DevTool finish, there's also this flag called force patch refresh. I know you guys have all worked in a recipe that had like 20 patches, and the patches were like 1, 2, 6, 5, 9, like 1, 1, 1, 1, and whatnot. And the patch numbers are all out of order, and it's kind of like a hassle to look at. And the patches are being applied with so much fuzz that like, you know those patches are just not gonna be cleanly applied every time. Using DevTool finish force patch refresh, it will intelligently count all the like, it'll clean up those patch numbers so they go 1, 2, 3, 4, 5, 6, 7. It'll be really nice. It's really nice, and it also cleans up some of the fuzzing. Yeah?
This reads like a Mortal Kombat fatality.
Yeah? Oh yeah, force patch refresh.
Does
Yeah.
that apply for all the patches or just ones that were generated by it?
No, it will do all the patches that you have listed in your source URI. So that's what's really nice about it. Yeah. So I highly recommend just memorize this flag because it's useful. It's useful.
So it resequences all the patches in the right order?
Yes. It's very nice. And it corrects for fuzzing. Like if some of the patches were applied with fuzzing, it will adjust the line numbers and everything. It's nice.
Does it adjust the subject lines as well?
I don't think so. Like yes, it does. Not the comments, but yes, the like the hashes at the top. Yeah, they get changed.
Very good.
Hmm?
That's cool.
Yeah, I think so. Yeah, and then there's like some other ones for DevTool that are also very useful. Like you can get the latest version of specific recipes. You can check upgrade status. You can use DevTool to upgrade specific recipes, and you can see like yeah, and you can use these subcommands to check if it's easy enough to just upgrade with DevTool. So you can check beforehand, check upgrade status on BusyBox. It goes and does some stuff, and I can't remember. Yeah. Okay. So that's DevTool. DevTool is very useful. Do you guys see why I love DevTool? Why it's very useful. All right. Any questions about DevTool? Yeah.
Yeah, so the patch days, so it does that when you start at like an edition session with DevTool?
Yeah.
So is there like a way to do it like just a single time I want to rebake my set of events?
Sorry? Like
Does
what?
that even make sense? Like, let's say I have a set of patches that are wrongly numbered and then we just want to do it in a single, like we start to start an editing session with DevTool and then like.
As far as I know, you have to do DevTool modify recipe and then DevTool finish --force patch refresh. But I know you saw the flag being used somewhere else, right?
Update recipe.
Update recipe also has that flag? Okay, so you can use that. But again, you still need to do DevTool modify first.
Okay, but that makes sense, just like two events.
Yeah. Oh, and a great thing about DevTool modify is that if that source code was just a tarball or whatnot, it does git init in the workspace for you so that you can edit the source code with Git, and all you have to do to apply new patches is just make commits in the workspace, and it'll automatically generate patches out of each commit that you've made in that workspace. It's very nice. That's why I prefer it when I'm patching like any specific recipe, because I just have to interact with that code base like any other code base. I just make my changes, commit them, and DevTool finish is smart and creates patches out of my commits. Automates a lot. It's really nice. Oh, this is not a video. Yeah, and then the next one I want to show you is run QEMU. So right now, I'm going to show you how to use run QEMU to debug your kernel. And of course, I'm going to use NeoVim as the front end for debugging the kernel. So the first command like that I want to show about run QEMU. So do you guys know what QEMU is? Yeah? Perfect. So I want to run QEMU on the specific machine I have. And I want no graphic because I don't want a new window popping up. I want it in my terminal. I want everything in my terminal. And for some reason, I would get kind of errors regarding like networking if you don't throw in slurp, which is like user space rootless networking. I can't remember exactly the purpose of it. I just know it works well when I add that in. But yeah, so these are so when I run that, I get my target machine running in QEMU in my terminal, and now I can interact with it how I want. Very convenient. I think it'd be very, very cool to use regularly. But yeah, so that's run QEMU. And then I want to now I want to use run QEMU to debug the kernel. So I need to pass some. So I run the same command, but I pass some arguments to QEMU with the QEMU params. This just tells it to like stop and wait for me to attach to it. And then boot params, no kernel address relocation. Like I don't want the randomized memory locations of the kernel threads and etc. And yeah, oop, perfect. So I pass that to the kernel via the boot params, and then I obviously start debugging the kernel from Vim because it's so nice. And so then I go target remote to the specific port, and then set a breakpoint on start kernel, and then I can start stepping through the kernel line by line. I think this is incredible. I think this is just an incredible like learning tool just to learn how like the kernel's initialization process works, and you can also use this to debug other things as well. And yeah, it's incredible. I really love this. So, any questions about run QEMU? No? Cool. Yeah. So that was run QEMU. And yeah. Okay. How am I doing for time? Am I going way over? No, coming up. Okay. So next tool is OE depends dot. Extremely useful. I wish I had known this for years because it's been so incredibly useful. So I'm just gonna play the demo I have recorded. So first off, you need to run BitBake-G on your recipe before you can run OE depends dot. This will create you a task dependencies file, which explains all the dependencies that you could use with other tools to show like a dependency graph. But here, I like my command line tools. I just want to see the dependencies in the command line. So it's great. I created that, and now I can run. So now I can run. Oh wait, no. Oh, that was the wrong video. Oh. Okay, let's see if I can just do it live. All right. 50. Okay. Okay, what did I? Okay, so we have that. So I wanted to run this command to see. Okay, so I want to run OE depends dot to see the dependency graph of, or like why busybox, the key busybox, got included into this recipe. So we can see exactly core image minimal depends on package group core boot on busybox. It's perfect. I have something, like I have that information immediately readily available. I know other people have had, myself included, have been pulling their hair out trying to figure out how a package got included into a build and whatnot, but this tool just lets you immediately know. It's very nice. And then we'll also go and show the next one to show what so pretty much these are the only kind of use cases for the OE depends dot. You got this W flag and this D flag. And the D flag shows you dependencies. The W shows you why it got included. And so we can just see the dependencies for BusyBox. Yeah, very nice.
Is the reverse tree?
Sorry, well, which one, the D or the W?
Is it the list of things that want BusyBox?
This one is the things, the W is the things that want BusyBox. The D is what BusyBox wants.
Okay.
Very, very useful. And then for the next video, I show package data util. Do you guys know package data util? No? Yes? Package data util, incredibly useful. If, say you have a path on your target in your embedded system, and you want to know what recipe included this path, you can use OE package data util, find path, specify the path on the target, and so we run this. There. We run this, and we see it tells us exactly this package provided that path. So now I know exactly, but wait, don't get ahead of yourself. That's not a recipe, that's a package. So what recipe provides that package? Oh, I thought this was my terminal. This is a video. So now we can use lookup recipe to go and figure out which recipe provides that package. And oh, yeah, so what provides that package? And then we see libpam is what provides libpam runtime. Great. Now I want to know what files this libpam package provides. Oh no. Oh, first I want to see all the possible packages that that begin with libpam. So I could use libpam with a wildcard and see that all of these packages exist for this this glob that I have here. And then I want to just know all the files that are inside this package. I can use list package files on that specific package. It tells me exactly what this package is going to install. Again, very useful if you want to validate that your capital files variable is set correctly in your recipe and the thing that you're adding is correctly getting added to that package. Yeah, very useful. And then there's also package info. It just gives you a little bit of info. Yeah. So don't you guys see why that's useful? It's so useful. I personally love it. So that's OE package data util. So, but the caveat of that is that it's for inspecting packages. So you obviously need to build your image first before you can get any of that information because it's doing it based off the build output of Yocto. OE run native. I found this was pretty cool. You can run, like, instead of having to install a tool on your host machine, you can just use the native one that you built with BitBake. And so you can, oh, I need to play the video. Yeah, you can just go, you can just run OE run native, the name of the package, the name of the package, and then the commands that's in that package. So I ran ninja native and ninja-h. So I think that's really cool. Sometimes you need to run this command first, but what's really nice about OE run native is that it will tell you, oh, run this command first. So you don't even need to remember the first command because it'll give you the heads up. Yeah, and then yeah.
Do you have any way to know like all native package available?
Sorry?
Do you have any way to know like in the list of native package available?
A list of native packages available. OE package data util, what was it? Yeah, list packages. I think, I just want to validate this because I don't want to lie to you. List packages, wildcard dash native. Let's see if this works. Nah. Wait, was it list packages?
Yeah, it's because native is an automatic recipe suffix.
But they still, I believe they still show up in these because they still get built as a package called that, wouldn't they?
can make anything Dash native.
Mhm.
That's fine.
Okay. I still want to. What was the? I still. Yeah. Okay. Okay. Yeah.
It's still private, but
Yeah. Exactly. Yeah. Just like yeah. Yeah. Perfect. And so finally, I'll stop torturing you guys. The very last tool is build history, collect source rev. This would have came in so handy, like a project ago. But pretty much what this does. Oh, sorry. Did you have a question? No. Oh, no. Sorry. What this does. So I finally found the name of the tool. This is the tool. What this does, it will find all of the recipes in your source code that depend. Whose source URI has auto rev. So the source URI is floating and can change. This command will find all of that for you and spit out like the valid BitBake code that you could put into your code local.conf to version lock those floating values. So very nice. And the demo doesn't actually show it doesn't show any floating ones because I believe the current build history. Oh, you need to inherit build history for this to work as well. So that's why I had that earlier in my local.conf. Yeah. So -A just will show all source revs, so not just the floating ones. And you see it spits out valid syntax that you could just go and put in your local.conf. So that's super cool, super useful. Yeah. Yeah. So that's those are all the tools I wanted to talk about. Yeah. Yeah. Any questions? Yeah.
So I have one question. All these tools, because mostly I'm not a developer from for the embedded, right? So what I know is Toaster. Are all these tools available in Toaster?
I don't know if they're available. They're command line tools, so I don't see like a use case of like using them through the Toaster UI. And I was assuming the Toaster.
Toaster normally use BitBake, right? So all the layers, recipes, all this stuff is available in Toaster, and you can do stuff with them using BitBake. So my question is, are this is only this is independent of BitBake or is built inside BitBake?
Mostly like all of these source codes, so all of these tools, they come packaged with Pokey, and they all most of them depend on BitBake, and they're all just command line tools. I personally don't use Toaster a lot, so I don't really know too much about how you could interact with these tools via Toaster. So I guess I don't have an answer for you.
Yeah, it has some of those features, but it's its own way of doing some of those features.
Oh, okay.
So it's more like an overlap.
Okay.
If you prefer web interfaces.
Okay. Perfect. Any other questions? Yeah.
Can you provide us your README file?
Huh? Sorry?
Is it possible to have your README file?
Oh, to provide this? Yeah, this is on my GitHub, and I'm going to share it. And all the videos, all the videos I have for each of them, those are all going to be on the GitHub as well. So yeah, there's no audio in any of these videos though, but I want to try to also share the video that I'm recording right now. It should be cool. Yeah, but see, I think these tools are pretty dang useful. I don't know about you guys, but yeah. Hopefully that wasn't too gross to look at with all the white text on a black background. But yeah, any other questions?
I like the Falcon Millennium speed of light animation you had between transitions.
Oh yeah, very nice. It's gorgeous. Oh yeah, yeah. Me too. Perfect. Any other questions? No. You guys are all gonna go use these constantly every hundreds of times a day now, right? Perfect. All right. Thank you guys.